Welcome to increasing, decreasing and stationary at a point. So the first thing is the rules that we need to be aware of. So we learnt this when we actually did little pluses and minuses on curves in the Year 11 course. So when we did little pluses, that was when the curve was increasing or when the gradients were greater than 0. So that's that first point, which is if f dash of x is greater than 0, then the curve is increasing. Where the curve reaches a turning point, that's where the curve we call is stationary. So the gradient there, or the f dash of x, is equal to 0. That's the second point. So if f dash of x is equal to 0, then the curve is stationary. And the third one is when we put the little minuses. So they were where the curve had a decreasing or a negative gradient. So that's f dash of x is less than 0, then the curve is decreasing. All right, let's have a look at some examples. So for what values of x is the curve f of x equals x squared plus 4x plus 2 increasing? So we know to be increasing, f dash of x has got to be greater than 0. So the first thing is we find f dash of x. So we differentiate and we get 2x plus 4. That then has to be greater than 0 to be increasing. So we make 2x plus 4 greater than 0, minus the 4 and then divide the 2, so x greater than minus 2. So if we were to sketch this curve, all the values on the curve where x is greater than minus 2, we would have little pluses next to because they would be increasing. The next one, differentiate y equals x cubed minus 3x plus 1, and then we're going to find whether it's increasing, decreasing or stationary at those 3 points. So we'll do them individually. So let's start with x equals 4. So differentiate first. So if you differentiate x cubed minus 3x plus 1, you get 3x squared minus 3. So the first one, when x is 4, we just sub 4 into f dash of x. So 3 lots of 4 squared minus 3 gives us 45. That's greater than 0. So at that point, it's increasing. Using the same derivative, but now when x equals 1, so we sub it in and we get 3 lots of 1 squared minus 3. That equals to 0. And when your f dash of x equals to 0, you have stationary point. And finally, when x equals 0, we substitute that into the derivative. So 3 lots of 0 squared minus 3 is minus 3. That's less than 0. So at that point, it is decreasing. All right, final example. Find the stationary point on the curve f of x equals x squared minus 2x plus 5. So we know that stationary points occur when f dash of x equals to 0. So the first thing we have to do is find f dash of x, so that's 2x minus 2, and we let that equal to 0. So 2x minus 2 equals 0. If you solve that, you get x equals 1. And because we're finding the stationary point, that means we need a y value. So we sub x equals 1 back into the f of x up the top, and you get y equals 4. So the stationary point is 1, 4. Thank you.